Hello everybody and welcome to another video of Programming for Data Analytics, video 14. Today we're going to keep going where we left off last time, which we were talking about the data types in Python for storing large amounts of data, which are lists, sets, dictionaries, and tuples. And so far, I just noticed something. Oh yeah, I was like, is tuple spelled correctly? But it is. It's just that I put everything in plural except tuples. So I was like, something looks off with that. But yeah, so we mostly be focused on talking about lists and dictionaries. So we are going to first start off by finishing that. And if you watched the last video, I had a bit of a breakdown because, lists were being faster than dictionaries, which is kind of wrong. And yeah, I was like, what is happening? So in between the two videos, I went ahead and panicked, and then I Googled, and I found some documentation that would support my claim that dictionaries are indeed faster than lists. So that I can show that to you. So I will go ahead and just show you a graph and call it a day on that argument. I will let it up to you to experiment and see if I am right or wrong. But hint, the entire internet agrees with me that dictionaries are faster. And I did mention the reason why at the end. I was kind of guessing it, and it was true. So here's the catch. Building a dictionary is slower than potentially building a list, because a list you just dump things in there and you're good to go. But more than that, the real power in a dictionary comes in the lookup, right? Because think about the example that we said. We were talking about the phone numbers and all of these things. The power in dictionaries is not in building it. It's in looking data up that you can get it instantly. And our program was biased because we only had one lookup. And we were comparing one lookup there with one lookup in the list. So sure, the list was faster to insert, and then the lookup might have taken slightly longer, but we weren't really, it was such a negligible amount of time that it just kind of went by unattended. The real way that we will be able to actually compare the codes and get them working is if we actually wrote code that did a large amount of lookups. And then if we did a large amount of lookups, would you start to see the divergence between a dictionary being very fast with all these lookups consistently and the list being variably but ultimately averaging out to taking n time, which is way, way slower. How slow are we talking about? Well, I went around and looked online and I found one book, which I'm going to go ahead and show the cover of. This is Fluent Python. And in this book, they have a graph. So this is by Luciano Ramallo. And ultimately, it shows how long it takes in terms of search for items between dictionaries, sets, and lists. Now, we haven't really talked about sets yet, but you can see that they're pretty good too. So let's look at this and analyze it. So this is kind of like the graph we were talking about when we do the graph for sorting between, n squared and n log n and n. So that kind of applies here. It's the same concept that the number of items to search through, so the number of comparisons, and the time it takes, okay? Now in this case, they're saying seconds. They probably ran it on the same machine, and that's why they're able to use seconds as a time measurement. But you can see that this is a linear growth. Between the larger the size, the longer it takes. And it makes sense that it's a linear growth because it's a linear search time when you're searching through an unsorted list versus doing binary search, which would be log n, right? So this is a linear growth. But interestingly enough, look how small and how slow this grows when you're using a dictionary or a set. That's because this is that constant time. And really, this should almost be flat, but the only reason it's not flat is because hashing does have some computational time involved to convert that into an actual index to look up, and there may be a collision or two, which would slow it down. But as you can see, these things are insane by factors of thousands faster than the list. You just have to have a serious amount of searches. So I've seen this with my own eyes when I did the Alzheimer research, and that is going to be public data set, so you were able to play with it yourself, and you can change the data structures back to list and see how it slows down. So believe me when I tell you that I have seen this with my own eyes, the insane factor of optimization you can do by using dictionaries and sets, which I use both of them. Fortunately, the last example with one lookup, you could see that lists were faster. That's not to say lists are bad. As you can see, when you're doing something quick and dirty, lists can get you there. But when you're going to do something where you're going to have a lot of lookups, a lot of searching through the data that you store, that's when you got to stop and consider, okay, maybe I shouldn't store this in the list. Maybe I should store this in the dictionary or a set to make it faster to look up. In the case of the Alzheimer data, there was a lot of lookup because I had to store the data once and then I had to look up matches between the data and I have to iterate to the data lots of times. So instead of doing that with a dictionary, I can just hash things very quickly and get going very fast. So, again, sorry that I couldn't show you a live example of that. I have to generate a lot of random lookups, but because I'm generating the words randomly, it might not be the best way to achieve that. So, just try it at home if you would like. You can generate a dictionary with like 1,000 numbers and look up that way versus searching through a just normal list versus dictionary. Okay. So, having said all of that, we can go ahead and go back to coding. So we have our shameful example of a dictionary. But nevertheless, it does show you how to look things up in the dictionary. And actually, let's go ahead and just jump right into a couple of other useful operations that you can do with the dictionary. Okay? So, duplicates are not allowed. As I said, they will just overwrite. You can print the length of a dictionary by calling the length function. It'll tell you the number of keys that are currently in the dictionary. So like that. You can print out, you can store any kind of data type in the dictionary. So, just like a list, you can mix and match numbers and words and lists within lists and those kinds of things. If you use a type function, what you're going to return from a dictionary is going to be class dictionary. Oops, I should be writing that on here. So you get that. You can also use is-instance stuff to figure out if this is a dictionary or not by comparing it against dict here. And ultimately, it's a little bit hard to prove to you that dictionaries are great, but they are. You just have to know when to use them. Just understand when you're storing data. If you have a data that you have multiple pieces of data associated to one item, such as like a profile of someone and they have a social security associated to it, it makes sense to store it in the dictionary because then you can look it up very quickly that way. But if it's data that you're going to want to store in, by different things, like that you're going to swap it and now you're going to store it by name of people or by their job type or whatever, then a multidimensional list may be beneficial to you that way. It's really going to depend on what you want to do with the data. The limitation to the dictionary is that it's very easy to look up a key, but it's not particularly friendly when you're accessing values of that. Okay? So, in fact, if you want to get the values of a list, all the values of a list, of a dictionary, you can say something like, let's say your dictionary is called D, you can say values, and that's going to return to you a list of values, just like if you print out keys, it'll return to you a list of keys in there. If you do .keys. But if you're trying to get the key value pair where you're getting it from the value, that's not particularly easy to do. You can check if a key exists or not by saying something like if, and then put in the key. So like, let's say car. If car in D, then you can check whether this key exists. And that's another important thing. So if you try to, let's say you want to access, of course, if you're doing something like this, let's say you're looking at key K and you're trying to insert in something like the word high. If the key exists, it'll replace it. It'll replace the value with high. If it doesn't exist, it'll make it. But here's something risky. If you just flat out say print, and then you say D like TO, and that key does not exist, your program will get an exception and will terminate. It'll give you an error and say the key does not exist, invalid key or something. So you have to be careful about that. And the way that you can be careful about that is that you can basically put this in an if statement. So you can say like if TO in D, then go ahead and actually query it. This seems a little bit inefficient. It is, because you have to do 2 checks in the way, because you have to search through the list of keys to see if that's there. But then you're protecting yourself from invalid access of keys, which, ideally you don't have to do this because you have a list of keys or you know what you're doing. But if you do have to do that situation where you don't know if a key is present or not, you have to do it like that. And that's going to cost you a little bit of speed. But still, the dictionary will be much nicer. Okay? So those are the different operations you can do with the dictionary. We will see some examples later on that we can use them with actual data. I do encourage you to use them again, depending on the formatting of the data. It's a decision you're going to have to make. If you're still unsure, then just contact me and I'll do my best to give you advice. Okay? So that concludes dictionaries. And I promise you that the next 2 are not as long. So let's go on and talk about sets. So sets, as you saw, is just as good as dictionaries. So the best way to think about sets, you can think of the mathematical way of sets, but which is kind of where they come from. But for those of you that are not familiar with sets in math, the best way that I can think about it is think of how dictionaries works, but you're only storing keys. You don't care about the values. So there might be situations where you want to store data, like a bunch of names. Let's say you want to store all words in the dictionary, and like you're not storing any values associated with those keys. So the reason why you're doing this is because you might just want to check whether something is in a set. So for example, let me give you an example that I did. So when I was doing the Alzheimer's data, I was looking at the condition of a bunch of clinical trials, and so I was looking to find all the neurodegenerative diseases all the trials that involve neurodegenerative diseases. And so a trial might be a trial for like cancer, or a specific kind of cancer probably. It could be a trial for like, I don't know, leukemia, or it might be a trial for like COVID-19, this condition, et cetera, et cetera. I wasn't interested in those. I was interested in things like Alzheimer's, Parkinson's disease, Hampton's disease. It's called Hampton's. What's the name? It's Huntington's disease, I think. Or like cerebral palsy and other of those neurodegenerative diseases. So I had a list of them. And I use a list, actually, in Python. And so whenever I saw a trial, and it wasn't just, by the way, like a list of the names, but like I had variations of the names, like Alzheimer's misspelled, abbreviated, all these kind of things, because I wanted to find any kind of match that would be similar. I also use like Liebenstein's and all the other fancy things. Don't worry about that. But just as a simple example, I was just using the different variations of the names of the diseases. So what I did then was, like, again, prototyping. I didn't care about optimizing that at that point. I just put the list of the diseases and then I ran the code. And it worked. I would basically look at the condition of a trial and then look up in my list of diseases or conditions that I care about. And then if it was listed there, then I would store that trial as something to look at, as a potential neurodegenerative disease trial of interest for me. Okay? So I did that for all the trials, and again, it worked. It was slow, but it worked. And then I said, okay, once everything was going good and finished, I said, can I optimize it? And so my optimization came as following. The lookup time of comparing the condition name with the list of conditions that I cared about, which was not that big, but it was still somewhat big, that's what was taking time. It was searching linearly to that list. And even if I ordered it alphabetically, unless, I use like binary search or something, it still took time. And so that's where something like sets comes in useful. I could have used a dictionary because that's, as we said, it's constant time, but there isn't really like a value to this. It's just a bunch of keys. And really all I'm checking is whether something exists in the list or not. So like I'm checking whether the item is a subset of the set kind of thing. In a way, you can think of it that way. So that's where sets come into play. Sets are, first of all, they are unordered. So when you think of a set, there isn't a particular indexing to the set. So you're not able to say like, okay, give me the 5th item of the set. No. These things don't have any ordering whatsoever. You can't index them. Okay? So they're unindexed. Okay, so ultimately, because you don't know what order they are in, you're not allowed to have duplicates, which is very important, because if you think of math, you shouldn't, like, you just don't, like, it's just not allowed to have duplicates in a set. Like a set in math, you just have items ones, and they're different from each other, right? So what is really, really, really powerful with sets is that I can check whether something belongs to a set super fast, like hash table fast, dictionaries fast. And that's all that's good for. And that's all that is good enough in my case for, because I just needed to check whether a condition was one of the ones that I cared about. And voila, sets did it for me. And that was one of the major optimizations. I could see a very noticeable change just by that single update to a set. And I did a lot of things like that too with sets. I'd say I use more sets than dictionaries in that specific project, but dictionaries were also useful. Especially once I actually generated the files I cared about, I used the NCTID number as the key value, and then everything else was part of the as the key, and everything else was the value. So there are collections that are unordered, unindexed, and there are no duplicates. Very useful again when you're trying to search whether something is part of something else. Okay, there's a match. So a lot of matching sort of rules and things like that. The first thing that you should know about a set is how to create one. And is that in here? Yeah. So I will post a reference to W3 Schools for sets because I like that one a little bit more than Geeks for Geeks for sets. Ultimately, if you say something like S, like that, Python, I can't do curly braces at this point. Python will assume you're making a dictionary. So if you want to make an empty set, it's kind of weird, but you have to write the word set in parentheses. It's a function, okay? And that will make it into, it's a constructor actually. We'll talk about that when we talk about object-oriented programming, but ultimately that is making a set, empty set, okay? So that is how you make an empty set. Other ways that you can make a set is by actually not making it empty and inserting things immediately. So another way you could do this is you could say, you know, let's just say Alzheimer's, Parkinson's. I'm not writing the full names, but you get the idea. MCI. Is it MCI? Yeah, it's late, and so on. And yeah, you just close your curly braces if you're able to use them. There we go. Okay, so that's a set. And if you print it out, you know, it'll look like this when you print it, and so on. And what's cool about it is that, like I said, you can add items as needed be. So you're not limited by that. If you want to add an item to a set, you use the word add after it, so s.add, and then you can insert what you're looking for. So I don't know, I'm blanking out on all the diseases for some reason, but let's just say you're adding another version of Alzheimer's, like the full word, okay, something like that. So you can add items to your set that way. What else would be useful? Well, remove, I guess. Remove is remove, so you just do s.remove, and all these operations are really fast, like the remove especially. That, you know, maybe maybe the same situation with dictionary where it's a little slower than the list, but again, you do this because of the lookup. Like if you want lookups, dictionaries and sets. Sets when you don't have a key value pair. Dictionaries when you have key value pair. So if you want to remove Parkinson, or let's say you want to run NCI, then you just go ahead and do that, and it'll throw it away. You can also use the discard, which will work the same way. There is a difference between them, actually. So remove, if you run remove and the item that you're trying to remove is not present, it will throw you an error and the program will die. Whereas discard will try to remove it, and if there's nothing there, like it is here because I'm removing it twice, it will not raise an error and just kind of ignore it. So that depends on what you want it to do. If you don't know if something is present and you want to remove it in case it is, go use this card. If you know for a fact that it's there and you want it to be an error if it's not because that means something else is wrong, then you want to use remove. There's also pop, but like weird things will happen, so I'm not even going to mention that because pop usually removes the last item of something, and if you do that with a set which is basically unordered, who knows what's going to get removed. So they really should remove that, but they left it there. So let's just say that's playing with fire if you use it. So anyways, how do you actually use a set to actually quickly access things? Well, you just basically ask whether something is there. So you can say, if, or in a loop or something, whatever, if, else in S, your code. And that search in S, it's, if it was a list, it would be a linear search. Whereas with a set or dictionary, it's super fast with the hashing. And you'll be able to pretty much immediately get that lookup back to you. Okay? So very powerful. If you want to iterate through a set because you want to do something to it, then you can just use a for loop for that. So you could say like for I in S, and that will give you each item. But you can't expect like a specific order. It's unknown and it could change. So just be aware of that. So this is useful if you're just trying to copy the values or modify them in some way or another, like lowercase them or something. But you typically don't want to like change them anyways. So just beware that it's random. Like you don't know what order you're gonna get them in. You might get like Parkinson's person here. Okay, we don't know. Big mystery. Okay, so those are sets. Like I said, I'm going pretty much quickly because once you know dictionaries, sets are kind of the same thing. Just think of the mathematical usage of a set. Again, a lot of the times when you're creating your code, you're doing it by hand, you're developing the algorithm, you're turning into math a problem to make it easier to then convert into a computer. And if in that math equation or problem you're doing, sets come into play, set theory, like for example, you're doing, just from data structures, like when students are doing the minimum spanning tree of something, you can use sets for that. So that would be something that you could use Python sets for. But it's up to whatever you're doing. But like I said, the most practical example is what I told you. You have a list of things that you want to look through and see if something is there, you want to flag it. So you're looking at that sort of lookup table. That is where sets are going to shine because you don't need a key pair value, so dictionary is overkill. So just keep it lean and do a set. Okay? And the last one of the day, keeping the lecture short, I hope, is going to be tuples. Tuples is the one that I least use, so I can't really tell you much about them in terms of like practical usage of it, because I prefer to use classes and make my own objects. But it's a math thing, I think, as well. So if you're in math and you have like a tuple concept, then you can use it. The big things with tuples is that they are ordered. So they will come in the same order when you run them through a loop. But the big difference here, and this is meant as an optimization thing, is that they're unchangeable. So when you make a tuple, you can't ever change it. You can make a brand new one that is the same one but like modified, but technically you're making a new one out of it. You just can't change an existing one. Okay? And they're useful because you can typically store a collection of the other three data types: list, sets, and dictionaries. So you can make a tuple of like pairs of data, essentially. To declare a tuple, you basically, let's call it T. You put parentheses and then you list what you want to store in there. So, for now, we're just going to store 1, 2, 3. Okay? So it looks kind of like a function or something. It's kind of wonky looking. But again, once you make it, you can't change it. And the cool thing is that you have one variable storing multiple pieces of information. Right now, this might be like, whoa, this is amazing. And sure, it's cool. But once you learn about objects and classes and that kind of data structure, then this is kind of whatever. I can make my own custom-made objects that contain whatever data I want. Mixtures of dictionary sets and lists and even tuples in there. So that's why I'm not particularly fond of them versus making my own objects or other data structures. Okay, but yeah, the important thing is that they do allow duplicate values. But they are unchangeable. Okay, and they are ordered. You can get the length of a tuple by using the length function as with other ones. You can, in theory, make a tuple with one item in it, but it's kind of a weird Python thing that you would have to make something like 1 comma like that. That is a tuple with a single item, and that's just some weird syntax rule, because technically if you make this, then that's not a tuple, because Python just kind of throws away the parentheses because it's just like, oh, this guy just randomly added parentheses, and it just becomes a single integer. So that's one weird thing, what's kind of in my list of why I don't like tuples, because when you got to remember weird things like that, that's when I have a problem. I didn't mention, but like, if you call the type function, you will get class here, tuple, I believe. And then for the sets, you get sets. It's kind of obvious, but obvious maybe because I know it, but maybe not to you, so I should mention it. If you want to make a tuple that's empty, you can't just do this with parentheses. Like, let's just say you're making tuple called t1, and you can't just do that. That's I don't even know what's gonna happen. I'll probably give you an error. So just like sets, you actually have to write tuple here, and you got to put parentheses to make an actual tuple. You could also enter into the parentheses the actual tuple you want to make, but you would need another set of parentheses. So this would look like that. Which at that point, it's like, why are you doing this when you could have just done this, right? So yeah, as you can see, I am biased against tuples because I'm not a fan of them. But ultimately, it is what it is. Use them if you want to. Don't use them. But just like break and continue, you should know they exist, so that if you see one in code, you understand what it is and you're not confused about what are all these parentheses doing and can I modify it? No, you cannot. So again, I don't like tuples, I don't really use them, but I know what they are, so that if I see it in somebody else's code, I know what is happening there. And I know not to try to mess with them and change them because it won't work. So that's the important thing, okay? So remember, you're learning not just because you want to use this, but also because you are going to be seeing it in other people's code potentially, and you need to be able to understand what they do. So that's it. Those are the 4 major data types. Of course, last video covered the first 2, and now we covered the second 2. And the last few videos have been a little bit longer, so we're going to end this one short. So from here on, we are almost done with the core principles of Python here. We still got functions and maybe exception handling that I would like to cover. But once we're done with that, then we can actually finally start doing some of the fun things with data analytics, right? But we have to learn these fundamentals first. So having said that, thank you all for watching. This has been a mini series that I made, I guess, for the last 4 videos that I just recorded back to back. So it's good though, because it almost felt like one massive lecture. But if I had made it one massive lecture, you would have all falling asleep by hour 4. So I'll go fall asleep now. No, I'm actually pretty energized. I like this stuff. Python is fun. It's much funner than C++. You can do so much more things and so much less work. So good times, good times. Anyways, I wish you all to have a great time coding Python, and to have a great time on the weekend or whenever you're watching this. So until next time, take care and stay safe.